Hi everybody. So in this video we're going to take a look at the principal quantum number and how that principal quantum number relates to understanding the structure of the periodic chart. So to begin with, some of you might have looked at the periodic chart and wondered, why is it that we have the first element, hydrogen, over here? So there's the atomic number 1, so it has 1 proton in the nucleus. And when we go to the second element, it's way over here on the other side of the chart. So number 2, helium, 2 protons to the nucleus, is sitting over here in the last column. So they're widely separated. But then when we go to lithium, number 3 is over here, and then 4 is right next door to it. And then we've got a big jump before we get to number 5. Well, this odd arrangement might seem inconvenient. You might be asking, why don't we just put it all in a box or put them all in alphabetical order? Wouldn't that be easier? Well, actually, sometimes alphabetical order is a little bit easier, and we have tables that do just that. But this structure is telling us about how electrons are ordered in an atom, and especially their order with respect to energy. And so the first part that we're going to discuss in this video is the so-called Bohr model of the atom. So in the Bohr model of the atom, it's kind of like a solar system model. We have the center of gravity here. Actually, it's really the nucleus. It's filled with protons and neutrons. And then these blue dots out here are electrons that are in orbit. It's a very handy model. It is certainly wrong. We know that it's wrong. But to cite George Box, all models are wrong, but some are useful. And this one is particularly useful for understanding at least one aspect of the structure of the periodic chart. So these letters, K, L, M, and N, they represent energy levels or shells. And these shells are ordered so that K is at the lowest energy level, then L is at a higher energy level, etc. We go to M, N, and then not shown, or O and P if there are enough electrons to fill out those shells. Now you might wonder, why is it that we start with K? Well, that is a little bit more of a historical oddity and has less to do with the science and a little bit more about scientists just kind of second guessing themselves. We use various techniques to try to probe the innermost parts of the atom, and what the early scientists found was that they thought that this inner shell might actually not be the most innermost shell of all of the shells. They thought maybe with more advanced techniques, there might be other shells that would be in here. And if we found other shells, then you can work the alphabetical system backwards. And so instead of starting with K shell, maybe you'd have something that would start with the D shell. And there would be D, E, F, G, H, I, J, K, etc. Well, it ends up we never discovered any of those innermost shells. It ends up that even with our more advanced techniques, it looks like K really is the innermost shell. And when that shell is full, then we move on to the L shell. When it's full, we move on to the M shell, etc. And there's one other aspect to this that I want you to note, and that is the way this is drawn. Notice that the K shell is the smallest shell. It only contains 2 electrons, here and here. And that's all it can hold. It can hold 2 electrons and no more. And so if you have a nucleus that has more than 2 protons, let's say it has 8 protons, where are those extra 6 electrons are going to go? Well, they'll go into the L shell. If you have an even bigger nucleus, let's say you have a uranium atom with 92 protons, well, we're going to fill up a lot of shells. The L shell can only hold about 8 electrons, not about 8, but exactly 8. And so that brings us back to the periodic chart. The way that it's structured vertically is that we're showing the filling of the K shell. So in that previous diagram, there were only 2 electrons. And so hydrogen with 1 proton can only have 1 electron that will be sitting there in the K shell. But helium has 2 protons, and it can hold 2 electrons. And once it has that second electron, that K shell is now filled. Now you still might ask, why don't we put the helium atom over here? And when people talk about the arrangement of the periodic chart, decades ago at least, some people were tempted to put helium over here. But the reason why we're putting helium in this last column is in this last column, we have the so-called noble gases. Because when a shell is full, when the outermost shell is full, then it's very unlikely that those elements will form compounds with other elements, and so they don't interact with one another, and they're called noble gases. After the idea that you have a stratified societal order and the nobles are at the top and they don't interact with anybody. So coming back to the Bohr model, we have the principal quantum number n. That would be 1. That's the first shell. We call it K as an historical exonent. This would be the second shell, also known as L. The third shell is M, etc. You keep on going down, ordering the principal quantum number n and the letters in alphabetical order. So that represents the vertical structure of the periodic chart. And then as we move left to right, this helium atom represents a filled K shell. This neon atom represents a filled L shell, etc.